Hey guys, Mr. Adamson here. Welcome to another lesson on identifying and naming compounds and writing out chemical formulas from word equations, balancing, and identifying what type of reaction we have. So the first thing we're going to start with again is identifying and naming the compounds that we have. And so if we go through, we have iron, we have copper sulfate, iron sulfate, and copper. So we know that iron is a metal, and it's simply just Fe. That's it. If we go to copper sulfate, we have copper 1 sulfate here. Now this gets a little more tricky because most of the elements on the periodic table have one kind of stable form for the most part. Their isotopes aren't super stable, so they're not really listed there. However, we get certain elements on the periodic table here, and they're known as multivalent elements. And they'll be identified with Roman numerals because they're going to tell you what ionic charge to use. And whatever Roman numeral number you have there, that's what the charge is going to be of that element in the compound. So for this one here, we have copper, which is Cu. And we know that Roman numeral 1 means 1 plus charge because it's a metal, it has a positive, it's a cation. And we have sulfate. From looking at our polyatomic ion sheet, we know that sulfate is SO4 2-. Now we have to put this in a compound. We don't leave it written that way. And so what we're going to do is we're going to cross drop our superscript charges here into subscripts and get rid of the plus and minus sign. So what that is going to look like is Cu, this 2 again comes down here, SO4, and we're going to take a 1 and put it over here, but we don't have to write 1. So right there, that formula is done like that. And we have a metal with a polyatomic ion here, and we know polyatomic ions are made up of 2 nonmetals, so therefore this is an ionic compound. The next one, we have iron 3 sulfate. Again, iron being a multivalent element because there's more than one stable form, which helps identify it using the Roman numerals. So we have Fe, and we know the 3 then therefore means a 3 plus charge. And we have sulfate again, which is SO4 2-. So again, we want to cross drop these charges, and that is going to give us Fe. The 2 comes down to the Fe, get rid of the minus sign, SO4 3. Now we don't want to have 43 oxygens, we want to have 3 SO4s. So this is where we're going to put brackets around the SO4s, so we have 3 SO4s. And again, we have a metal here, or a cation, with a polyatomic ion, which is made up of 2 nonmetals. So we have a metal with a nonmetal, therefore we have an ionic compound again. And then we have copper, and copper is not a diatomic element, neither is iron, so therefore they can exist by themselves. So now we've identified and named our compounds here, and we have 2 that are ionic, and our single elements are not diatomic, so like I said, they can exist by themselves. And now what we need to do is write out our reaction. So we have iron, which is Fe, reacts with, so react meaning plus sign, copper 1 sulfate, so we talked about how that was Cu2SO4, to produce, so we have our reactants producing our products, so produce arrow sign, and iron 3 sulfate, and we already wrote that out, so it's Fe2 bracket SO4 close bracket 3, and copper, so plus copper. Now we need to write the states, however. Iron metal, we know that that is a solid, unless otherwise told. Pretty much all metals are solid. We have copper sulfate, ionic compound, so therefore solid again. We know that of their properties. Another ionic compound here, iron sulfate, so this gives us another solid, and copper, a metal, natural state to solid also. So 4 solid components in this reaction. Now we need to balance, so splitting up our reactants and products here with that line, and we have FEs, we have 1. However, on the product side, we have 2. So what we're going to do is put a big 2 in front of there, and that gives us 2 FEs. So those are balanced so far. Then we go to our coppers. On our reactant side, you can see we have 2. However, on our product side, we only have 1. So we need to balance that out, and the easiest thing to do again is just put a big 2 in front. Therefore, they are balanced. Now, we need to look at our sulfates, and we can look at them as a whole, as the compound together. We don't have to split up the actual sulfur and the oxygens. We can look at it together because we have sulfates in our reactants here, and we also have sulfates in our products here. So we can count them as one thing. So we have an SO4, and you can see on this side in the reactants we have 1. However, in our product side, we have 3 SO4s. That little 3 applies to everything within the brackets, so we have 3 SO4s. If we didn't have a sulfate on our reactant side over here, we'd have to split them up, like I said before, and that means that we'd have 3 sulfurs, and then you go 4 times 3, that gives us 12 oxygens. But luckily we don't have to do that, so we have 3 SO4s on our product side here. Therefore, they aren't balanced. So what we have to do, and the only thing we can do, is put big numbers in front. And in order to get that sulfate to balance, we put a big 3 there. Now, those are balanced. However, that is going to screw up our coppers, because you can see now that we have 3 times 2 gives us 6 coppers over here, where we already have 2 right here. So what do we need to do? We need to get rid of that 2. So I gotta erase that, put my Cu back there, and I need to put a big 6 in front. Now that gives me 6 coppers. And so therefore now we have a balanced equation, because we have 2 Fe's, 2 Fe's. 6 coppers, so 3 times 2, 6 coppers. We have 3 SO4s, because this big 3 applies to everything through the compound here. And we have 3 SO4, so that little 3 outside the brackets applies to everything in. So that gives us 3 again, and 3. Therefore we have a balanced equation. Now what we need to look at is what type of reaction do we have here. And we've talked about formation, where 2 things become 1, or 3 things become 2. Decomposition, where 1 compound becomes either 2 compounds or 2 elements, or 3 becomes, or 3 becomes 2, or we talked about hydrocarbon combustion, where we have a hydrocarbon plus oxygen always produce the product of carbon dioxide and water. We don't have that here. What we have is a single element plus an ionic compound yields us an ionic compound plus a single element. And so therefore we know that we have a single replacement reaction. Replacement. Run out of room there. So, and the reason we can tell is because when we have a single element here in a metal, and we have an ionic compound, which is a metal and a nonmetal together, we can see in our product side over here the 2 metals, so iron and copper, switch places. So whereas iron was by itself here, it is now on a compound, and copper is by itself here. So a single replacement, you have either the metals switch places or non-metals. So we could have had a non-metal here. So say for example we had chloride right here. And what would have happened is the chloride would have switched places with the sulfate. And therefore sulfate would have been by itself over here, and chloride would have been in place here. So anyways, the metals will always switch places with the metal, and the non-metal switch places with the non-metal. So therefore we can see now that we have a single replacement reaction. Went through the whole process of naming the compounds we have. So we didn't have any molecular here, we did have, well, in a case we kind of had molecular in the sense that we had our polyatomic ion, which is 2 nonmetals together. but they exist in a specific state, whereas a polyatomic ion is always, for example, if you have sulfate, is always 1 sulfur and 4 oxygens. So we have ionic compound in the sense that we have a metal with nonmetals. So we don't have actual compounds by themselves, which are 2 nonmetals together, and then we just have single elements here and no diatomic elements, where, like before that we talked about in previous examples, oxygen can't exist by itself. It would always be O2. So hope you're able to learn something from that today. Thanks for listening.
Made with Doodlecast Pro.